Hi everyone and welcome back. So I was just about to tidy up and do some rewiring to try and progress this project, and I've noticed that there's a bit of a problem. If I just zoom in here, you can see it says battery drain amps 14.36, and that's just not right. There's not 14 amps flowing through the circuit at the moment. So just to explain, yeah, battery drain amps, so that's amperage coming from the battery to either the inverter or to the secondary circuit, which is the microcontrollers. So what happens if I just go over here? They're all connected together there, the battery positives are all connected together into this box with the red cable sticking out. Then it flows through the switch thing here, and then it goes through to the inverter. Well, the inverters actually, two inverters. But actually this is the inverter that's going to be used. So then it goes through the 250 volt circuit, and then it comes back through the neutral, or what here becomes the minus. From the minus it goes to the shunt resistor, from the shunt resistor back down to the minus of the batteries. And the second circuit is just a 24 volt circuit, which is this thin blue wire here, and that goes to a buck converter which is behind this panel, and that feeds the 5 volt devices, and then that returns back to the shunt resistor, as you can see here with one of these blue wires. So we've got two wires coming off here, you can see them both here, and these two wires, if I just follow them along, they go to here. Now specifically where though? They go to here. And what that does is that goes to the amplifier here. From the amplifier, from the grey cable, it goes down to here, the grey wire, sorry, and that goes to A1. And then from A1, this Arduino Nano compiles a lot of figures and it sends it to the Node MCU, and then the Node MCU sends it off to my server and also to this panel. It also updates the panel at the same time. So the problem is here somewhere. It's not anything to do with the server, it's here. So the problem exists here, so let's see if it exists here. And it does exist here. I've had a look through the serial, and it does exist. It also exists here. And the way I know this is because if I was to disconnect this, in fact I'll show you, I'll disconnect it. So this is the voltage coming out of the amplifier. So right now there should be a drop across here of probably 1 millivolt, if that. Probably, yeah, not even that actually. And if I was to test that, which I'll do here to show you, I'll just set this to, I don't know, 20 volts for now. I'll connect a ground to somewhere. I've got to do camera work one-handed here. But I'll connect this to a ground, any ground. They should be pretty similar anyway. So I've connected one to a ground there, and I'll connect the red wire to this, if I can do this one-handed. Yes, I think I just, yeah, oh no, let's try again. Have I got it? Yeah, I've got it. So this is from the amplifier, this one here. So I've got the shunt resistor minus and the shunt resistor plus into the amplifier, and then this is the out pin, which actually goes into the Arduino, but this is the out pin. And if I look at the voltage, it's giving a voltage of 2 volts, and that definitely is not right. And you could be thinking, okay, well the chip over here has a set gain of 20, so for that to be 2 volts, then there'd have to be a 10 millivolt drop. Is that right? Or 100 millivolt drop? 100 multiplied by 10 is 1000, and multiplied by 2 is 2000, which is 2000 millivolts, which is 2 volts. So yeah, if that's 2 volts out of that amplifier, and the amplifier's got a gain of 20, that means that the voltage drop across the current shunt is 100 millivolts, and it almost certainly is not that. But let's check it anyway. So I'll disconnect this. Now the minus, I'll have to somehow connect it to, see if I can get a grip on that. And then the plus, I'm going to have to set this to millivolts as well. I know it's going to be less, it's got to be less than that because there's no current flowing. -5, hang on, that's not right, there's not a good contact there. There we go. 0.2 millivolts. So 0.2 millivolts multiplied by 10 is 2 millivolts, and then multiplied by 2 is 4 millivolts. So that should be reading 4 millivolts after being amplified by a gain of 20. And it's not reading 4 millivolts, as you know, it's reading 2000 millivolts or 2 volts. So I've got a problem, and we've successfully diagnosed using these methods that the problem is that that amplifier chip is broken. And I don't know how that's happened, but it is broken. So this chip is an AD8202 amplifier chip, and I'll need to now take this down and put a new chip in place, which is inconvenient, but when I do that it should fix this problem over here. So that's a bit of a setback, and that's going to be some messing about, but I'll do it and I'll let you know how it goes. One of the things I've done is to pull this off and then desolder the broken amplifier and solder the new amplifier on in place, but I've actually not done it as straightforward as that. What I've done is I've soldered on these headers. If I can just pull this off, there we go. I've soldered on to 2 headers instead, and what it means is if this chip breaks again, all I have to do is that, just push it on, and that's much easier. So I've done that. I've also ripped out all of those wires from all over the place here and tidied them up. So I've used an Ethernet cable, which you can see here. I've took the pairs out. The brown pair goes underneath here and goes nowhere. The green pair goes over here for the relays. I'll just zoom out a bit more so you can have a quick look. So the green pair goes to the relays, the orange pair goes to 5 volts and ground, and the blue pair goes to the current shunt or the amplifier. So I'll just show you that other side. I'll just go over here. So you can, first of all, we'll trace the blue wire, current shunt wire, go up the cable, down there, across there, and then down here, and then here it just spreads into wherever it needs to go, and you can see the blue wire goes underneath and then through here to the current shunt. Okay, so the orange wire goes down there through the cable, follow the cable down there, and the orange cable goes to here, which is a buck converter. But the orange wire, where is it? It basically connects over here to these 2 clips. These 2 clips are really good, by the way. I only bought them a few weeks ago. I've done a post this here video. I'm not sure if I've released that one yet. But these clips are excellent. They're so stable and they're so stiff. So anyway, the 5 volts is connected there via this little orange and white wire. And finally the green wire. The green wire goes across there, same path as usual, comes to here, through a hole, and then out through here. And then through here it goes to the signal terminal of the relays. However, I have a bit of a problem. So if I just go over here again, the whole idea of this whole thing was to fix the amplifier and the battery drain current measurement on the screen here. And this is where the problem lies. So I come to test it, and to test it, of course, I use a load. So I've plugged something in here. It switched over to solar, as you can see here. So that means that the inverter's on, which it is. You can see over here the inverter is on, and it switched over to solar, and it is there. So therefore, this socket here is solar power. But if I add a load to it, if I just turn a load on, that's what happens. And that is the RCBO, which protects the circuit from when it leaves the inverter. So that RCBO on the right, that's C16, 16 amp RCBO, that's tripping, and at the moment I don't know why. Either that thing is broken, this RCB over here, sorry, RCBO is broken, or energy genuinely is draining through somewhere else other than the neutral wire. So there's some issue. I don't know what it is at the moment. I don't know why it's happening, but I've got to sort this out, otherwise I can't even test the load.